Howdy chemists! We've reached the end of week 3 of our Intro to Organic Chemistry course, so I thought I'd start off with a little bit of an organic chemistry joke. How do you show a paradox with organic structures? So think about it, and there we go. It's a paradox. Ha ha ha. All right, moving on. Highlights from this week. So our week followed its general pattern that we've been seeing lately. You know, we participate in discussions, we have readings and lecture videos. Many of you are attending the Zoom sessions, or at least watching them after and sending me questions. We're starting to use the Waterhole discussion board a little bit more, which is great. We have our lab. You know, hopefully we kind of understand how the class is going to work. But I think our biggest highlight from this week was that we either have taken or are about to take our first unit test. That opened up on Friday. Several of you have taken it already, and then closes on Sunday. So if you have any questions or concerns about that, please let me know as soon as possible. So our learning outcomes from the week, we were wrapping up our Unit 1 material about the chemical reactivity of alkenes and alkynes, those unsaturated, our aromatics, and then our addition polymers as well. And you participated in some discussions about that. You got to see the key difference between how halogenation works for an alkane, which we learned about last week, and then an alkene, which we're learning about this week. And both of them can be halogenated, but there's some definite differences. First of all, even just in how easy that happens, an alkene can be readily halogenated. If you watched that bromine reaction, you see the color of bromine disappear very, very quickly and very easily, as opposed to the color doesn't disappear at all in the alkane, though we actually could get it to happen with UV light or strong heat, but even then it would be relatively slow. But it's not just that. At the molecular level, at the atomic, or what I call the Miss Frizzle level, what's happening is also different. And also we hear that difference in that we call one a substitution reaction and the other an addition reaction. And in a substitution reaction, we have to take one thing off and put another thing on. So when we brominate an alkane, we take a hydrogen off, we put a bromine on. When we brominate an alkene, we're adding. There's nothing taken off. We add right across the double bond. We have our double bond, and it opens up, and then both of those carbons now have, I call them jazz hands, where they can grab on to something new. And so one grabs onto a bromine, the other grabs onto another bromine from the diatomic bromine molecule. And we've now have, not only has it been halogenated, but it's no longer unsaturated. So we lose that double bond, and it becomes then just a single bond between the carbons. So we looked at those differences. You also hopefully enjoyed learning about aromatics and that benzene ring, which is unique in so many ways, and even just its history, but it's especially unique in the fact that it does not chemically react at all like you'd expect for how unsaturated it seems to be. It appears in its Lewis structure to have 3 double bonds, so we would expect it to brominate readily, which it does not. You'd actually have to do a lot of chemical work to get a bromine on there. And if you did, it would end up being substitution. It'd be pulling off a hydrogen and replacing it with bromine, not opening up the drawbridge and breaking that double bond. So they do not show the chemical reactivity that we would expect to see for the level of unsaturation that they must have. And that gets into the fact that those resonance structures, they actually don't quite have double bonds nor single bonds, maybe more like 1.5. They have that sea of electrons above and below the ring that makes it a very, very stable cyclic structure. And then you also got to learn about polymers. Polymers is a very general term, but we focused on addition polymers for alkenes this week, where when that double bond opens up and the jazz hands grab onto another, they're grabbing onto another previous double bonded carbon as well, and then we can build our things like PVC and polyethylene. So what's going next? We are going to then be jumping into Unit 2. You're going to notice the pace does pick up a little bit right now, and that's because we've had a couple weeks to get the, pattern of the class and get those course questions out of the way, and now we're ready to really buckle down and hit this content hard. So we'll be covering all of chapter 12 this week. So really get going, read that book early. We'll be looking at several new organic families, alcohols, ethers, and thiols, as well as phenols. Oh my. So what should you be doing? What's next for you? First of all, if you haven't already, complete your Unit 1 test, and then do see the feedback once it's available. The feedback won't open up until 24 hours after the final due date of the lab, so looking at probably Tuesday unless you want to stay up till midnight on Monday. Complete Lab 3 if you haven't already. This lab's a little bit tricky, so be patient. You can redo a lab if you're unhappy with your score up until the due date. Make your initial post to the week discussion, which should have posted this morning, and then you're going to do your follow-up posts where you really should be demonstrating some growth in your knowledge after you've done the reading and videos from maybe your initial thoughts. And then be working through that weekly to do learning outcomes and checklist page. And there is an extra credit opportunity that's actually available to everybody this week. This isn't a first come, first serve kind of thing. And I'm not going to go over it because you can read it there, but I will tell you, I want to take the pulse of the course a little bit and see how this online experience is going for people and find ways that I can help you out and make the course even better. So good luck. Stay safe this weekend and prep for some more organic chemistry. And I'll see you guys soon.